All right. So, hello and welcome everyone. Welcome all of you to this particular session of definite integrals. So, this is the lecture number 2 of definite integrals, and we're gonna talk about the properties of definite integrals in this particular session, right? So, I hope you have already been and watched the previous session before you come and watch this particular session of lecture 2 on definite integral. Okay. So, as we start, before I start, I actually want to discuss about the two of the important homework problem, which I already gave to all of you in the previous class, right? And before I start discussing about the class content, let me announce the important thing that we have already started our live batches. And in each of the live batches, you can enroll for the live batches where you can get access to the classes. So it's basically like a small group of tuition where you can take the classes one-on-one, or you can take the class in a group of 5-10 students, right? So, and in order to get access to all the live classes, the material, and you want to study from us directly, you can always contact us on this particular number that is given on the screen. Please use this particular contact number to contact me and my team if you want to get any help, right? So with that, let's get started. So in today's session, I'm going to talk about the mostly I will be talking about, first of all, I will be talking about the properties of definite integrals. But before I start to discuss about the properties, because if you see the question of definite integrals, it's all about properties, right? So how well you are able to solve the question along with the properties, that will help you to judge and access the situation, right? So with this, let's get started, right? And let us first of all get with the question that I asked you in the previous class, right? So I gave you two homework problems. I hope you can see the question over here. So the homework problem that I gave to all of you, did you all solve the question? Were you all able to solve the questions? Right? Were you all able to solve the question? Okay. I hope you were able to solve the question. So and the first question, the answer of this first question should be coming out as pi upon 2 times of a into b. Okay, where your a and b, both of them are positive, right? I hope you have tried to solve this question and you've got the solution like this, right? Now, if you let us see how we actually get this solution. So if you're someone who is not able to solve the question, I'm just repeating the solution over here. So what you will do over here in this question, so if you look at this integral over here, the integral is mentioned from 0 to pi by 2, which are the two limits of the integral, and it starts from, and it's given as dx upon a times, sorry, it's basically given as a square, yeah, it's given as a square cos square x plus b square sine square x, right? That's the given question over here, right? So if you look at this problem over here, the simplest way to solve this question is basically, if you take cos square x as common from the denominator, the result will be like it will go up in the numerator and will become secant square x dx whole divided by a square plus b square times tan square x, right? So the main motto to give you this question is basically to help you to see how the definite integral question changes in terms of substitution. Okay, so in order to solve this question, you have to simply assume this particular term tan of x as some variable t. So let us assume tan of x some term variable t. So if I do that, then my numerator will become secant square x. So this particular part of secant square x dx will be equals to dt, right? So therefore, this secant square x and dx in the denominator will be simply equal to dt, right? So therefore, this I can replace as with dt upon a square plus b square t square, right? So I can write this simply as this, right? But when I do the substitution, please don't forget that when you do the substitution, you have to do the substitution of the limits. Or you can do the question in the reverse way, that you solve the question in the substituted variable, but after you put it back, you can put the variable back in terms of x, and then you can put the limit. So you can do it both ways, but I'm doing substituting a variable. So if I put x equal to 0, my t will become equal to 0, and I put x equals to pi up by 2, my tan of x is not defined, or I can say it's like infinity, right? is tending towards infinity, right? So therefore, the limits of the question in this case will be as 0 to infinity over here, right? So then I can solve this question in further, and I know this is a very simple question because you have already solved many types of question like this type, right? So this will be equals to 0 to infinity. So the question over here will be t square plus a square by b square. So you took out 1 upon b square as common. So 1 upon b square is constant that will taken out. And therefore, the solution is basically tan inverse of bt upon a, and then we will have the constant part, which is basically going to be 1 upon ab, right? Because there will be like b by a coming over here, so which will become 1 upon ab, and then we have to put the limit, which is going from 0 to infinity. So if I put in and solve it for this question, the result is going to be equals to 1 upon ab times, now tan inverse of infinity is basically like pi by 2 minus 0. So the result is going to be equals to pi upon 2 times AB. Okay, so pi upon 2 times AB is the solution for this definite integral problem. I hope this question is clear to all of you. I hope this question is clear. Please let me know if this question is clear or not. Is this question clear to all of you? Online tutor, please turn off the camera blur effect. Let me check. Uh, the thing is that the writings are visible, right? Okay, so it's basically green screen effect, okay, over there. So I hope the writings is visible, right? Yeah, I think probably the writings are visible, so don't get worried by that thing, okay? Online tutor. Is that okay? Great. Any questions regarding this question over here? Okay. I hope this concept of substitution for definite integral is clear, right? So this type of question you have solved a lot in the previous chapter of definite integral. So I don't think that this will be an issue to all of you, right? Now, similarly, I asked you to solve the question. I asked you to solve this question of dx upon 4 plus x square, which is going from -2 to 2, just by using a substitution 1 upon x, right? Now, why did I wanted you to make the substitution 1 upon x over here? So that you can learn about another very important thing. That is basically when you do the substitution, you have to make sure the substitution is basically continuous and defined everywhere in that particular interval where you're doing the integration, right? But over here, when you are doing the integration from -2 to +2, there is a point x equal to 0. But when you have that point x equal to 0 and you're substituting some variable like 1 upon x as some another variable t, in that case, the problem that occurs is basically that at x equal to 0, so at x equal to 0, this particular thing will not be defined. So therefore, this kind of substitution, we cannot use it to solve the question, okay? We can solve the question by using a substitution if I break the interval of the limit that is going from -2 to 0 and then 0 to 2, right? So at x equal to 0, I break the question and then I solve it, right? So that is how you actually need to take in mind that when you are doing substitution, please be sure that x, that particular variable you're substituting for x, has to be continuous over that particular interval of the limit, okay, in that integral question, okay. I hope this question is clear to all of you, right? I hope this question is clear. If you have any question, please let me know. Okay. So let's now discuss about the other topics, right? So let's go on with the discussion of the topics as well. So in today's session, we are going to start with the properties of integral. Okay. So from today onwards, we are starting with another new topic, that is properties of integrals, property of definite integrals, right? So this is going to be the most important topic, especially of this particular chapter, and especially of any question of your JEE Mains and Advanced. Okay. So once you understand the properties of definite integral, you will be in a position to solve and answer all the questions that will be coming up, right? And you can use the different techniques of the properties in order to solve difficult problems, right? Let's see some of the important properties one by one, right? So in today's class, I'm not going to cover all the properties in today's class, but I'm going to take up the first initial basic properties so that you can actually get started with some of the few questions, okay? And then I'm going to give you some homework problem to try out so that you can also work out with this homework problem and have a practice over it, right? So let's start with the very first property. Okay, so let's start with the very first property. So the first property of integral is that if I have an integral which is going from limit a to b for the function f of x dx, then I can write the same integral for different variable, that is again going from a to b for f of t dt. Okay, so when you change the this is not different thing. There is not like substitution. It is the same thing, is that we are just changing the input of the function. If you change the input of the function but the function remains the same, you are not changing the function. But in case of substitution, you are basically doing a different function, right? So you're doing a transformation between the domains, right? So you are basically taking, in other words, I can tell it's like a Jacobian, right? So whereas in this question, you are not changing the function, you are keeping the function as it is, you are just changing the input or the variable, the name of the variable. Okay, so you're doing a transformation in x equal to t, something like that. So you can also call this a substitution question, like x equal to t, so your dx should be also equal to dt. Okay, so this is the very first simple property of definite integral. I hope you are clear with this property, right? Now if you want to look into the proof of this property, I can give you a small proof to satisfy all of you. Is that the proof of this question can be given as, let us say I have phi of x is the primitive. Okay, so is the primitive of this function f of x. Okay, let us say phi of x is the primitive of this function f of x. Therefore, derivative of this function phi of x will be equal to this function f of x, right? So therefore, from here I can also do one more thing, is that I can change the variable and write that d of dt, d by dt of this function in terms of t is also equals to the same function in terms of t, right? So you're just simply changing only the variable over here, right? So therefore, the integration from a to b for this function f of x dx is equals to phi of x for the limit a to b, and that is basically given as phi of b minus phi of a, right? Now similarly, if we do the for the other one, if we do the for the other one, since f phi of x is a primitive, right? So for a to b, if I take f of t dt, then it can be given as phi of t for the limit a to b, which is again equal to phi of b minus phi of a. So therefore these two results are equal, and therefore in this case I can say that if I change the variable of the function like x equals to t, the limit is the integral is the same. I hope this is clear to all of you. Is this question clear to all of you? I mean the property is clear to all of you, right? Okay, so this is the very first and interesting property or basic property of definite integral. Okay, so after you are done with this particular property, let's now move to the next property. Let's now move to the next property. That is property number 2. Okay, now as we go on with the important properties, the more important properties we'll be seeing in the upcoming further classes. Okay, let's go with the property number 2. What does the property number 2 talks about is that if I have an integral which is going from x equal to a to x equal to b for the function f of x dx, is can also be written as minus of the integral, the limit going from b to a for the same function f of x dx, right? What did I do over here is that if I just replace the limits, if I just replace and change the limit, then there will be only a negative sign coming into the question, only a negative sign. So if the limit of the definite integrals are interchanged, then this value changes by a minus sign only. I hope this is clear, right? So if you want to look into the proof of this question, I can the property, I can show you the proof. The proof is fairly simple. Is that, let us say again let us talk about that f of x be the primitive, be the primitive of the function f of x. Okay, let phi of x be the primitive of the function f of x. Then in this case, if I do the integral from a to b for the function f of x dx, then this is basically equal to phi of b minus phi of a, right? I hope this is right, right? Similarly, if I take a negative sign and then I do the integral from a to b, if I do the integral from b to a, from b to a for this given function f of x dx, then this can be given as phi of a minus phi of b. But don't forget there is a negative sign outside, which will make it again equals to phi of b minus phi of a. So which is again the same, right? So therefore, when you change the limits of the definite integral, it only changes by a negative sign. I hope this is clear to all of you, right? Now with these two basic properties, we are now basically going to head towards the most important property of definite integral. That is, sometimes people also call it as a King's property, okay, because it's the most important property, and with the help of this property, you can solve a lots and lots of questions. Let's try to see that particular property over here in detail. So talking about the third property, so the third property talks about that if I have an integral which is going from, let us first of all take the basic case, okay, going from x equal to 0 to x equal to a for this function f of x dx, then this can be given as, by this property, this can be given as the integral from 0 to a for the same function f of a minus x dx, a minus x dx, and this is the most important property, my dear students. Okay, so this is sometimes also called as the King's property. There is no scientist or mathematician called King's, but it is basically King's property because it is very famous in this chapter. Okay, that's why it's called King's property. Oh, sorry, the spelling of property doesn't has R, right? I hope this is clear, right? Now let us try to see how we come across this particular property, or let us try to see the derivation or the proof of this particular property. Okay, it's a very simple thing, and you can prove it very by simply by just doing some simple lines of substitution. Is that so? If I have this integral over here like this, and if I put in this place a minus x as some variable t, if I just see over this integral over here and I put a minus x as some variable t, then if I differentiate both the side, my dx will be equals to minus of dt. My dx will be equals to minus of dt, right? So if I take this integral over here going from 0 to a for the function f of a minus x dx, I can replace the same integral in terms of the substitution variable, that is, and then a minus x, so x equal to 0, then my value will be a over here and it is 0 over here, and then it will be a function or value of f of t dt, right? Now we have learned from the second property that we can change the limits of the variable and we can make it from 0 to a, and then there will be a, sorry, I forgot the minus sign over here because this dx is equal to minus of dt, so minus sign, and that minus sign will be taken, a minus of minus will become positive when you change the limits of the definite integral, so which will be equal to f of t dt, right? And again, by using the first property, I can write this simple expression from f of uh, that 0 to a with the limits, and f of t dt can be also given as f of x dx. I hope this solution is clear to all of you, right? So therefore, this is the most important property which we are going to use in order to solve some important questions, right? So I'm going to show you that how important this property is and how it actually helps you to solve questions, okay? But before I go on, let me discuss a bit about the geometrical interpretation of this question, okay? So let me just go through the live chat once again. I hope it is making sense and clear to all of you, right? Is this clear for all of you? Please give me a thumbs up. Is this clear? Okay. So let's try to understand the property of this particular property and how it is geometrically important, right? Now, this particular property is useful to evaluate definite integrals without finding the corresponding indefinite integral, which may be difficult sometimes to find, right? Now, what is the technique that I will do over here? Generally, why I call this King's property is that this particular property is mostly used in order to solve question where the summation of where the summation of f of x plus f of a minus x is some easy function to integrate, some easier function, let us say g of x, which is easy to integrate, okay, which is easy to integrate, right? So therefore I try to use this property so that I can get the sum of these two function and equals to some constant or some easier function which can be easy to integrate, and then we can get the definite integral and divide by 2 because both the definite integrals are equal, so we will just divide by the 2 to get the result of the individual integral. I hope this makes sense, right? So this function f of a minus x, so for example, if I just try to interpret what does geometrically it means that, so if I have any function like this, let's say this x-axis and this is my y-axis, and I have a function like this. I have a function like this, which goes from x equals to a to some x equals to b, right? The function goes like this. So, or maybe like from x equal to 0 to x equal to a, because I have the limits from 0 to a. So 0 to a. So when I go from the left to the right side, it is basically going in x. But when I go from the right side to the left side, it is going in terms of x minus a, right? So if this is my function for the graph, like y is equal to f of x, but if I just do a graphical transformation and I get the graph of the function y2, so let us say y1, this is y2, for the function f of a minus x, the graph of the function will just shift in its origin. So it will be starting from the maximum over here and it will go like this, right? It will go like this in the minimum over here. But the values, exactly the endpoints will be the same, but they will get just be interchanged, right? So this particular thing is clear. Therefore, the area under the curve over this particular y2 function and the area under the curve for the y1 function are the same. Okay, are the same. So the green area, so the area I'm plotting in the green color, okay, this particular area, that is area under the y1 curve, okay, the area under the y1 curve is equals to the area under the y2 curve. So this is also the geometrical interpretation of this thing, right? So you just do a graphical transformation in terms of x and change it to a minus x. The area remains the same, right? So that is the most important thing that you need to understand in order to understand this question geometrically. I hope this makes sense to all of you, right? Please let me know if this question is clear or not. Is this question clear? भैया प्लीज एनडीए का भी पढ़ा दो. श्योर श्योर, एनडीए एनडीए का भी कोर्सेस आएगा, ठीक है. एनडीए का जो एग्जाम्स है ना, उसका क्वेश्चंस काफी इजी होता है, ठीक है. तो उसके लिए एक बेसिकली वन शॉट लेक्चर्स आएगा, ठीक है. अभी मैं जनरली जो चीजें कवर कर रहा हूँ वो जनरली क्लास 12 स्टूडेंट्स के लिए हेल्पफुल होगा, राइट. तो अगर आप पहली बार कुछ चीज को पढ़ रहे हो तो ये काफी हेल्पफुल होगा आपके लिए. बट अगर आप स्पेसिफिकली एनडीए के लिए तैयारी करो, डेफिनेटली इस चैनल पे एनडीए का भी वन शॉट और क्विक लेक्चर्स भी आएंगे, ठीक है. हर चैप्टर्स के वन शॉट लेक्चर आएंगे जो आपको स्पेसिफिक एग्जाम के लिए प्रिपरेशन के हेल्प करेगा, राइट. So definitely I have that in mind. Okay, so don't worry. Okay, so I hope this question is clear. This particular thing is clear to all of you, right? So let's now try to see why why this thing is very important, and let's take one question to explain you this theorem over here, right? So let's take a simple question, okay? And with this, I will try to explain you. So let's take a simple question. Okay. The question is given as you have to integrate within the interval 0 to pi by 2, and the integration is dx upon 1 plus square root of tan x, right? 1 plus square root of tan x, right? So you have to integrate this particular function over here. Now, how will I do it? How will I do it, right? So very first thing, let's first convert this tan x in terms of sin x and cos x, right? So I can write the same expression, this integral as 0 to pi by 2, and if I write in terms of sin x and cos x, after simplification, it will become square root of cos x divided by square root of sin x plus square root of cos x, right? Now, if I just apply the theorem that I learnt over here, that is 0 to a for the function f of x dx is also equals to 0 to a for the function f of a minus x dx. Now, why do I do it? Because I know that sine and cos are basically orthogonal, and also they are complementary to each other. So I can write sine x as cos of pi by 2 minus x. Similarly, sine of pi by 2 minus x can be equals to cos x, right? So if I just use this thing, I can do this simple way. So I can write the same integral. As 0 to pi by 2. So the cos x over there will become sin x, right? And this will become cos x. So when I do this simple change over here, the denominator remains the constant, the denominator remains the same, right? So therefore, if I just add this two function, now I always talked about that when I add f of x plus f of a minus x, it becomes a constant or easy function to integrate, right? So you're gonna see over here. So let's say this is equation number 2, and this is equation number 1. So if I just add this first equation and second equation, I'll get 2 times of I is basically going from 0 to pi by 2, and the result is basically going to be like sin x square root of sin x plus square root of cos x whole divided by square root of sin x plus square root of cos x, right? So this is going to be the same thing, and it's going to cancel out and be a constant 1, right? So ultimately the answer is going to be answer is going to be integration of 1 dx, which is equal to x, and if you put the limit, it's going to be pi by 2, right? And then you put the integral, so 2 times of integral is pi by 2, so it will become half of pi by 2, which is equals to pi by 4. So your integral result is going to be equals to pi by 4. So the result of this question is pi by 4. I hope you can understand how easy it becomes when you know this particular property. So with this particular idea, I would like to give you some homework question to practice so that you can try to solve this question on your own, and you can see and how easy that by using this King's property, you can solve almost all range of questions. Okay. So let me give you the homework problems over here. Okay. So the first homework problem is basically, please try to integrate 0 to pi by 2 0 to pi by 2 natural log of tan x, natural log of tan x dx. The second problem, try to integrate 0 to pi by 4 0 to pi by 4 natural log of 1 plus 1 plus tan x, 1 plus tan x. The third problem is basically 0 to pi by 2 0 to pi by 2 sin x minus cos x whole divided by 1 plus 1 plus sin x cos x. Okay, very simple questions are there. Okay, just try to solve this. And one more question, which is basically an IIT JEE previous year question, that you can also, you need to solve this question as well. That is 0 to pi x times function of sin x. So please try to evaluate is equals to some constant times, 0 to pi is some equals to constant times of 0 to pi function of sin x. Okay, so please try to solve this question and tell me what is the value of this constant over here. So you have to determine what is the value of this constant. Okay, so there are 4 homework problems for this particular session. Okay, please take a screenshot of these homework problems and please try to solve this question once you come from the next class. Please take a screenshot. Please take a screenshot. Okay, from which college you have done your graduation? You can see all the information given in the description box. Okay, so please check out the description box of the video to know more about me. Okay. Okay, so with this, I would like to conclude the session over here. I hope you have enjoyed watching the session as much as